first time they're like, oh, it's not just a problem on a worksheet, it's actually something that I can use.
It's really neat how all of a sudden like everything just became one. You know, we're reading a history document and then it's like, okay, use that to draw up this, and then, you know, oh, that makes sense because we did the electromagnet, and then, oh my god, like all of a sudden the kids are like, it was just all so natural.
We both really understand electricity much more than we would if, say, we just made an electromagnet and started picking up paper clips.
Originally, we were talking to UVA and about 3D printing and using engineering to enhance science curriculum. And we heard about the Smithsonian pushing a 3D initiative. And so we collaborated with UVA to have students create a telegraph.
Really, it was sort of an open-ended project, and you know, the telegraph was a natural fit. For some of the stuff that Robbie has been doing in his class, it fit in with the science curriculum really, really well, electromagnets. And then with the stuff and the open-ended things we could do in the engineering classroom, it sort of became this, I don't know, this easy collaboration, and it was like, okay, you do that, I do this, and then boom, and he taught the content at first, and then I started teaching the kids how to do some of the design work.
We learned a lot about how the Veil telegraph was used, like during the Civil War, why they needed relays, so like if the electricity were to burn out, the relay would keep the fresh electricity going. It was nice to not only just make it for no reason, but really like learn how it was used. Yeah.
UVA contacted the Smithsonian and wanted to present it to the Smithsonian, and so we were actually invited up, and the students presented it to the bigwigs up there, and they were so impressed with it all that they wanted to continue collaborating with us and seeing how we could actually do this with all sorts of other innovations and inventions that are archived in the Smithsonian.
So this is the key. It has its own power source. Yes. And so when you put this, it sends electric signal here into this iron core, and then when the electromagnets are turned on, it pulls this down, which completes this secondary circuit, which then turns on this light and makes a very satisfying thing.
Really, my job in my classroom is to teach the science and apply the science and do some type of minor engineering. Eric's job is to teach the design and engineering aspect of it, and through that to enhance the science class.
I learn better when I'm experiencing it in front of me. Like reading and taking notes from a textbook, it doesn't help. It's just easier to understand something if it's right in front of you, and you can do different things to it or whatever it is, and like you can just see the reactions of it. It's simpler. You can make relations. It's easy.
Absolutely, they're learning, and you know, if our concern should not be can a kid accurately answer A, B, C, or D. I mean, it should be like what skills are they going to be able to really apply and use in life. And I don't see test taking as the #1 skill I want my kids to walk away with. I want them to be critical thinkers, problem solvers, and be able to apply knowledge. If you can't apply knowledge, it's not very helpful. And I think that's what schools need to become, is a factory of individual critical thinkers.